Okay, let's carry on. Anybody thought of any pressing questions while you're away, morning tea, pondering all the stuff you've learned this morning? Nothing? Right. Where were we? Okay, yeah, we covered that one. So if we go through that whole process to isolate a circuit, we identify it, switch it off, tag it, etc., and we come to do our test, and we find that voltage is still present. What are we going to do? So the first thing we shouldn't do is panic. I've definitely seen that, right? That's what happens when we do that practical task on those boards, and you guys flick the breaker off and you get the wrong one, and then you do the test, and I say it's still live 99% of the time. That's it. That's the end of the test, because most people will not recover from it. Because I feel like I've got a process that I've got to follow. Do I have to remember all these steps, and then I get to that step and something goes wrong, then it throws them off completely. So we must not panic. You know, we just reset. We go back one step. I've got to identify the circuit. I've got to do this, that, whatever. So the first thing that we want to look at is there's the wrong circuit protection that's been isolated. That's going to be the vast majority of the time. If I isolate it and it's still live, then I've got the wrong one. Especially, of course, if I'm doing trial and error, right? If I'm just flicking them off to see, then if I flick one off and I'm still live, then it's probably I've just isolated the wrong one. Yeah, the same for isolating switches. Might be the wrong isolating switch. The isolating switch is damaged or faulty. So that's possible. It's possible that I could switch something off and it doesn't actually turn off. So we could that would be something to check. The neutral is being switched. That's probably less likely. But what would happen? Let's follow that through. If I've got let's say a switch here. So I've got my neutral, and somehow we've wired the switch in the neutral. That's going to my load. And I've got my phase coming in there. So depending on how you test it, you may not even pick that up, right? So if I were testing phase to neutral here, and I've switched the neutral, it's going to look like 0 volts. Ideally, I'd be testing from there to there. And then even if I've switched that, I'm still going to show voltage, right? Because I've switched the neutral instead of the phase. That makes sense. So when I've switched off the circuit breaker or isolating switch or whatever, I've switched the neutral instead of the phase, I'm still going to show 230 volts even though I've switched it off. That makes sense. And you get weird stuff like when you get broken neutrals. That's what you'll generally find is that if the neutral's broken, you'll get weird 230 volts where you didn't expect it. Often you'll pick that up by getting 230 volts between neutral and earth. Because if I test the neutral here to earth, I'm going to have a live voltage, right? Even though if that's broken or switched. Cool. Doesn't happen very often. People don't often switch neutrals. The only time I've come across it that was particularly bad is in a situation where we had 2-pole switches. So you had the neutral and phase were switched. They were done deliberately. But there was like 6 isolators next to each other, and someone had run the phase for one equipment through one switch, but then the neutral back to a different switch. And so then the phase on that one to a different equipment and the neutral on that one. So they'd switch the neutrals over at the switch, which I won't go into all the details because it'll take hours, but worked perfectly fine. Because as long as those neutrals are continuous and everything is switched on, it's fine. It wasn't until somebody came to work on one of them, switched one of them off, then that's broken the neutral on a different piece of equipment. So the one that he was working on, it still looked like it was isolated, even though the neutral was still connected through the switch that was still on. But then they started having issues on the other equipment that they weren't working on. Somebody started complaining, have you guys switched this off? I went, no, we only switched this one off. And so, oh, this one's not working now. So they went to investigate that, not realizing that, they'd switched the neutral for that one. And then that means that in that equipment that they then started working on, or the one that accidentally turned off, when they started investigating that, all of the neutrals are live because they switched the neutral back at the switchboard accidentally. So that dude ended up getting a shock off a neutral. And I was only involved in that one because I was asked to part of the investigating team to figure out what went wrong. And yeah, so that's actually one of the reasons why we don't generally use double pole switches and don't switch neutrals. But there was in a fuel station, so in those situations we do use double pole switches. So if the neutral is being switched, that can cause us all sorts of issues. Okay, so once we're finished, if we're leaving a circuit isolated for whatever reason, tape up cable ends or use a strip connector, so we make sure that no live parts are accessible, right? That's mainly for the off chance that somebody does come and switch that back on while we're not there. We're leaving for the day or coming back next week or something. If somebody does switch that back on, then we don't want random wires poking up. Cables are protected against damage by tucking them away, so we don't leave cables hanging out the wall and running across the floor. Danger tag is replaced with an out of service tag. Again, as I said before, danger tag is something I'm working on now. Out of service tag is just for general equipment that is out of use. If you left the danger tag on instead of the out of service tags, it's not going to be the end of the world. So additional notes on our disconnection. So we talked about this methods of isolation. I think we went through all of these. Yeah, isolating switches, pulling the fuses, a circuit breaker, which is our main one, removal of load phase wire. So that's what I was talking about. You pull the wire out of the circuit breaker or out of the switch or whatever. Yeah, generally special circumstances like longer term, like I said, you might pull that out because I'm going to leave that disconnected forever or whatever. And in the case of a three-phase appliance, we make sure that we pull all three fuses, right? And I've done that before too. That's one case where I got a shock because I didn't pull out the right fuses, and I only tested one of the phases. I think I've talked about this before. And the other two phases were still live. Isolation must be foolproof in the sense that it must be impossible for someone to reliven the circuit while work is taking place. Take steps to ensure the power cannot be restored while you are disconnecting the appliance. Remove fuse completely or on circuit breakers, attach lock where possible. Ensure tagging procedures are properly carried out. Danger tags while work is carried out, etc. Look, there's no, I mean, what we're talking about there is making it so that nobody can easily or accidentally turn the power back on, right? But actually we're not, there is nothing that'll make it impossible. Someone could cut off a lock. Someone could open a switchboard and screw the wire back in. All of these things rely on, hopefully, the people doing it having enough sense or enough knowledge to know that they shouldn't be doing that, right? Which is an important point to note when we're talking about that tag out system, right? Because if we have a system where everyone uses locks, tags, etc., and we all go through the same education, not everyone will do this course, but everybody who's going to be an electrical worker has to do the same stuff. They all have to do the same exams. So if we all understand the same system, then there should be no electrical worker who's going to come across a danger tag and a lock and not understand what that means. So I guess that's another important part of what we're doing here. It's not just to keep ourselves safe, but it's so that we have the knowledge that if you come across something like this, if you come across something where the wire's been pulled out of the circuit breaker, and you think, well, that was that light circuit that I wanted to turn on. That's why it's not working. Someone has removed that wire. Then hopefully you're going to have enough knowledge to go, I probably need to make sure that something else isn't going on before I put this back in. Presumably, anything that somebody's done deliberately, you're not going to undo that without checking what's going on first, right? Do the disconnection, but make sure there is no possibility of any exposed or readily accessible wires or terminals becoming alive at any time while the equipment is away for repair, or of any disused wiring becoming alive. Danger can arise to the electrician or others from relivening the disconnected circuit wiring. So again, there we're talking about if we're working on a fixed wired appliance and we disconnect it completely and even maybe remove that appliance, take it somewhere else to be repaired, then we need to make sure that what is left behind remains safe. We should be attaching an out of service tag if the reconnection is not immediate. So if we're going to fix it and then reconnect it and everything's finished right then we just leave that danger tag on till we're done. But if we're going to leave the premises for whatever reason, then we must put that out of service tag on there. Ensure other critical circuitry is not left out of action. So whatever isolation that we've done shouldn't be affecting something else if you are leaving the site. Yeah, if it cannot be avoided, then it's okay while we're there, as long as everybody knows. But you're not going to turn off, you know, if I had to replace that, let's say I had to replace that socket up there, and the only way to do that would be to kill every socket on the top floor. Okay, it is what it is. But I'm not going to leave that all switched off while I go roaming around Auckland trying to find another socket, right? And the whole building has no power while I'm off doing something else. So then I might put strip connectors on the exposed cable, make sure it's tucked away, maybe even screw or tape something over the top of that, and then reliven that circuit for the period that I'm gone. Does that make sense? And it's not a great example, because if I came to replace a socket and I didn't have a socket, then I must be some kind of dummy. But you know, if it was a fixed wire appliance or something like that. Labeling, ensure labeling of conductors is correct, ready for reconnection. So actually, this is a really important point about repair, fault finding, or anything like that in general, is that we should always know. I cannot tell you how many times I've done this. Pulled something apart, you had to look at it and go, oh, okay, yeah, the red goes there, the white goes there. The yellow one is being used as an auxiliary. Okay, cool. And then you remember all that stuff and you go, yeah, I'll remember when I come to put it back together. And you come to put it back together and go, shit, where did the yellow one go again? I can't remember. I've done that so many times, I cannot count. It's just me overestimating my own ability, I guess. So making notes, putting physical labels on your cables is good. Just carry around a roll of white insulation tape. In fact, I probably use insulation tape for labeling more than I use it for taping stuff, because you could just whack a piece of white insulation tape on a wire and you can write whatever you want on there with just an ordinary ballpoint pen, and then you know. Now, in saying that, those are all things that I've done throughout most of my time as an electrician, but obviously nowadays your best option is what? Take a photo. So probably the majority of the time that I spent on the tools as an electrician would have been, say, from 2000 to 2010. So wasn't really an option. But yeah, nowadays just whip your phone out, take a photo, and then you've got it, right? So you can refer back to that later. There's no errors or mistakes. And motor rotation. Direction should be checked and appropriate notes made. If practical, this may involve running the motor before it's isolated. Obviously not feasible if it's burnt out, or maybe if there's some other fault there. With a three-phase motor in particular, right, the only thing that controls the direction of rotation of a three-phase motor is the polarity of my three phases. If I switch one, the motor's going to run in the other direction, which is awesome, because it means that you can switch a motor really easily. For a three-phase motor, you just switch any two of those three phases and it's going to rotate in the opposite direction. Fantastic. But if I'm removing a motor to work on it, I should check which way it rotates first. Make sure I know what the connections are, so then when I put it back in, it's not going to run backwards. Okay, our procedure for reconnection. We've all seen that before. No surprises there. So when we're reconnecting, make sure we've got no missing strands at the connection point or loose connections. I'm sure we've talked about that before. As we go through the course, I'll get more and more strict on this sort of stuff, right? In the kind of early days, I'll let you away with a little bit of that stuff. But as you get better, as your skills get better, then we'll be more strict on it. So we should be making sure that no strands in our cable are broken off. None of them are sticking out of the connection. There's no exposed copper showing, all of that sort of stuff, which I'm certain that we've talked about before. If we've got any damaged wire ends, don't be lazy. Don't be lazy and sit there and go, oh, it'll be fine. Just restrip them, reconnect them, put new lugs on if you need to. We need to make sure we're doing an insulation resistance test, which normally should not be less than 1 mega. Why does it say normally? Not different kinds of wires. Any cable should have an insulation resistance over 1 mega. If it says normally, that must mean there's an exception, right? Do we remember what the exception is? Yeah, hot water cylinder, a water heating appliance. Water heating appliance, generally hot water cylinder, but could be electric jug, anything that heats water. And the reason is, does anyone remember the reason? Who helped me test those water cylinders a couple of weeks ago? and we pulled that element apart, right? And what was in there? Yeah, magnesium oxide. So generally your water heating elements look like, if I cut it in half, so I see the steel tube on the outside, right? And then my wire is like a little coil in the center like that. And it runs all the way through. All coiled up, high resistance wire, whatever it is. And then around the outside is that white chalky looking powder. That's magnesium oxide. That's there to insulate that wire there, right? So that's going to be live. And then the outer is going to be in contact with what? The water. So if that outer becomes live, that's really bad news. Incredibly bad news, right? Because not only do we have a live element, but now all of the water pipes and all of the water in my house, it's going to be live. Imagine the fright you get if you turn the tap on and it zapped you. Like the water zapped you, stuck your hands under the water and you got a shock, which is literally what would happen if we got a fault in here. But we can't use traditional insulation. I can't use rubber insulation. Why? Or PVC insulation? Why not? Because it'll melt. It's hot as hell. It's literally a red hot wire in the middle there. If I put any sort of PVC between that coil or that conductor and the outer sheath, which is earth, then it's just going to melt. It'll be completely hopeless. So our best insulation is magnesium oxide, that white chalky stuff. Which if you haven't seen that, I don't know if I kept that element. Oh, we'll have a look. We'll find something at some point. Because it's really heat proof. It's a fairly good insulator and it's really heat proof. The one downside of that magnesium oxide, particularly in water heating elements, is that it is quite hygroscopic. So it will absorb water. So any sort of perforation, even a tiny one in that outer sheath, which will allow a little bit of water in, could cause that outer sheath, the water to go through to the center. And then we've got an earth fault, right? We're going to fail our insulation resistance test. Now, in most cases, you'll find that even a water heating element will still be more than 1 megohm, but sometimes it won't, particularly in an older one. Even a little bit of moisture in there can drop that insulation resistance, but it's not necessarily super dangerous. So just only for water heating elements, we give a little bit of allowance that, okay, it's probably going to get some moisture in there at some point. And so we can allow an insulation resistance of as low as 10,000 ohms. As long as it's more than 10,000 ohms, it's okay. It's kind of dumb, really, when I explain it all like that. It's like, well, why isn't everything 10,000 ohms? It's either safe or it's not safe, right? Like I said, the most dangerous thing that could happen in your house, if you had an earth fault, the most dangerous place you could do that is to your water system, because then it's going to zap you everywhere. There's no escaping that. But we're going to say, oh, 10,000 ohms is safe in the hot water system. It's not safe everywhere else, but it's safe there. It's either safe or it isn't. I don't know. Anyway, do our earth continuity test. It should not exceed 1 ohm. This is specifically for, oh, what is that for? 1 ohm for our earth continuity. What is it? Where is a 1 ohm earth continuity test a successful test? Not every wire. There's a specific answer to this. or no idea. And an appliance. In an appliance, 1 ohm is a satisfactory earth continuity result. For our main earth, so from our earth busbar in the switchboard to our earth stake, that's 0.5 ohms. For our earth continuity conductors, so from our earth busbar in the switchboard out to each individual earth or each individual earth wire on every sub-circuit, then it depends. It depends on the size of the circuit breaker and the size of the cable, which is in this table 8.1 and ASNZS 3000. It might be table 8.2, I can't remember. And ASNZS 3000 tells us what the earth continuity values for individual sub-circuits should be. But for an appliance, it's 1 ohm. Where do we find that information? Where would I get that reading from? Oh, come on. Oh, section 8 of ASNZS 3000. It's a good guess if that's what you're going for. But no, section 8 of ASNZS 3000 is about testing. Yes, but that's for installations. It's a great guess. You're right. If I was asking about earth continuity conductors in a building or something, then yes, the answer is section 8 of ASNZS 3000. Well done. That is for installations, but we're talking about an appliance. That should give you a clue. ASNZS 3760, in-service testing, in-service safety testing of appliances. That tells us all that information about appliances. Remember, those are our two most important ones. ASNZS 3000 for installations, 3760 for appliances. So I wouldn't expect somebody to remember section 8 of ASNZS 3000. That's impressive. What else? Switch on our circuit breaker. So we've done all our testing. We've reconnected our thing. We've repaired it. We've done all our testing. Then we can switch it back on. Then we do our operational test. So we physically make sure that it works. And then we remove our tags and we're done. Additional notes. That is exactly the same as the notes for the isolation. So we can skip that. So, safety tag system. Electricity safety regulations 106 states that safety tags or personal locks must be used if there is a danger of accidental livening after the isolation of an appliance or part of an electrical installation. For added safety, a lockout facility should be incorporated into the system. If so, it must be used. Electrical safety regulations 106.2. The tag system would then complement the lockout device typically at the switchboard. So let's all jump on and find electricity safety regulation 106. Just so you've got something to do rather than me talking the whole time. So everybody find that, read it, to see if we can absorb exactly what it says. Everyone found that. So it's not a super long paragraph, but it does contain a couple of little interesting pieces of information if you read between the lines. So it says that a person carrying out works on works or installations that are isolated from a power supply must, if there is a risk of unintentional enlivening of the works or installation, ensure that suitable notices warning against enlivening are fixed at a point where the power supply may be connected or restored. So it doesn't say that we specifically have to use a danger sign, but it says a suitable notice. So presumably then I could write something, right? I could just write one on a piece of paper and stick it on the switchboard. Do not switch this back on. It's dangerous. I'm working on it. Please don't kill me. And then it says that if works or installations have a locking facility for isolating them from the power supply, then any person isolating the works or installation must use that facility to lock the isolation. So if I can lock it, I must lock it. So if I read between the lines, then what does that also say? Exactly. If there's no place where I can lock it, then actually the rules say I don't have to. I don't have to. If there's a way for me to lock it, then I must lock it. If there's no way for me to lock it, if none of the switches are lockable or anything like that, then actually the rules say I don't need to. I still have to put a sign on it. I must put some sort of signage, some sort of warning notice on there, but if I can't lock it, don't have to lock it. Does that make sense? That's interesting, isn't it? Regulations, love this stuff. Any questions on that? All happy with that? Okay, that's a good question. So let's have a think about it. If I buy anything off the shelf these days, it will be lockable. Any sort of isolated, anything like that. Even circuit breakers, right? So they've designed those little weird staple clip things to enable me to do that. So if we had a situation where there was no ability for me to lock it at all, I must be looking at something that's pretty old. Now, this is an interesting point. Electrical regulations are never retrospective. Does anyone know what I mean by that? A couple of people nodding. No, I didn't. When I say that, does anyone know what that means? I don't mean you to say, yes, I know what that means. I want you to tell me what that means. Any ideas? Because electrical regulations are not retrospective. No? Okay. Sure, you can figure it out. What that means is whenever a new regulation comes into force, it does not apply to anything that has already happened. So if they say that every circuit in a domestic installation must be protected by an RCD, that means from the date of that regulation, anytime you put a circuit in, you must protect it with an RCD. It doesn't mean that everyone has to go and rewire their house. Yeah, that's a good example because that's a real thing. It does mean that if I put in a new circuit on an old house that doesn't have RCDs, I must put in an RCD for that circuit. But it never compels me to go and rewire anything or rebuild something that already existed, provided it was built and maintained under the laws at that time. Make sense? So if I've got switches, circuit breakers, whatever it is that are not lockable, if they're older, then there's no requirement for those to be changed. So it's not going to be the owner's fault, right? So what do we think? Who would be liable then if I had a situation where there was no ability for me to lock something out, and I followed the rules of 106, which said, what must I do? What's the minimum I must do? Put a sign on there, some way to notify somebody. So if I did that, but I couldn't lock it out, and then somebody switched it back on, and either me or someone else was hurt, who gets in trouble? Is it the owner? Is it me? So is it the person who switched it back on? The switcher? What do we think? What do you reckon, Soila?
The
person who switched it on? The fish? What do you reckon? Banana, potato. Nathan, what do you reckon? Yeah, okay, all right. We're all on the same page then. I think, yeah, it'll be the person who switched it back on, right? There's no obligation on the owner of that facility to provide that thing. As I said, there's no electrical legislation will ever be retrospective. So if it was installed before, I guess maybe if it was installed after, you're supposed to install things in a certain way and it wasn't done like that, then whoever wired it originally, it's certificates of compliance. So we must issue a certificate of compliance for all of our work and retain that certificate of compliance for a certain period of time. So actually, that's another interesting point as well. We'll come back to that in a second. Yeah, so if somebody wired it wrong or built it wrong, then they may have some liability, but the primary liability is going to be on the person who switches it back on, right? If we've done our stuff, if we've put our warning sign on there, and we weren't able to lock it, then whoever switched that back on is the dumbass. They shouldn't have done that. Yeah, and how would we know who's done that work? Well, a certificate of compliance, right? We have to issue a certificate of compliance for any sort of work that we do, and we're supposed to retain that for a certain amount of time. It used to be 7 years, but I think it's less than that now. I think it's 2 years or something. But that's an interesting one that I've always thought was a bit dodgy. Like if you, I don't know if any of you guys have ever come across this, but if you do certain types of building work, right, on a house, you have to have a building consent, right? And you'd be surprised at the stuff that requires a building consent. Changing a toilet technically requires a building consent. Yeah, I know, outrageous, right? Even if you swap it like for like. So in theory, none of us here would be allowed to do that work. We'd have to apply to the council for a building consent, and they'll say, you're not a plumber, you can't do that. It's crazy, right? Any alterations or removal to any structural elements of a house. So if you're taking out internal walls, if that's a structural wall, it requires a building consent. So then the question is, well, how do we police that? How do we know? Well, the building consent process, part of that process is that when I apply for that consent and it's approved, all of the documentation relating to that, so my building consent application, the approval, and then the sign off, because part of the consent process is the council will send out an inspector to sign it off once you're done. All of that stuff goes onto the, what do we call it? The LIM report for the house. So if you've ever bought a house, you go to the council. You don't have to, but most people do. You go to the council and you apply to get the, it's not the LIM report, actually, it's something else. But you apply to get the records for that building, right? And if you're smart, you'll do that kind of stuff. You'll have a look, it'll have usually have a house plan there, and you have a look at the plan and you go, this plan's got way more walls than this house does. What's going on there? And if you haven't got a building consent that relates to that in that file, then you know they've done something shady, right? Does that make sense? There's like, the house is twice as big as it is on the council records, then you know that, and there's no building consents in those records, then you know they've made additions that they shouldn't have, right? But there's no process like that for electrical work. I'm supposed to retain that certificate of compliance, but only for a certain period of time. So even if somebody came to me 10 years later and said, did you rebuild the switchboard in this house? I don't have to have any records. They said, well, we want to see your certificate of compliance. There's no obligation for me to provide that after a certain amount of time, right? None of that work goes onto the council records. So then if a house has gone through a number of owners over the years, they might not actually know. You know, if you did work for a specific owner, they know who you are, right? They could probably track you down again later if something that you did failed, even if it was 10 years later. But if the house has gone through a number of hands, the person who owns that house at that time might not know who did that work. And they can't go, it's not retained in the council files. It's not part of the information for that building that the council holds, because it's not, no building consent was required. And so there's no record, essentially no record. Yeah. But you've also got to give the building owner a copy of your certificate of compliance. But again, if it goes through multiple hands, and you know, nobody looks after that sort of stuff. I've always, I know it sounds crazy, but that's always been a comforting thought to me that, no, you know, no shady shit that I did 10 years ago is ever going to come back to haunt me, because there's no way that they'll find me. How are they going to track me down? If you want to be even one step shadier, don't fill in a certificate of compliance. Well, how are they going to find you? Nobody knows what work you didn't fill in a certificate of compliance for. The only way that could happen would be A, something really goes wrong, and so somebody is out to find you, and then again, the current owner in that building knows who you are, knows who did it. And if it's not the owner that you did the work for, then the chances of them tracking you down would be almost zero. How are they going to know? Who was the dude who wired that dodgy socket that set the fire to the building? I mean, I think it's crazy. I think it seems like a crazy system to me, because it's just so full of loopholes. And you think about building, it's really easy, right? Because anybody can be the, what's the word? Auditor, inspector. Every time you sell that house, somebody's going to come along and go, the council records don't have this on here. Something shady has happened. And with electrical work, none of that. Anyway. Oh, did I skip that slide? What do we got? Safety tag. Safety tags or labels, although employed extensively in overseas countries, are not used in New Zealand to the extent that they should. Their purpose is to ensure the highest standard of safety among those persons who operate, service, or repair machines and their associated power supplies and control systems. Yeah, I would say this PowerPoint slideshow is probably at least a couple of years old, maybe 5 or 6 years old. As I said earlier, 10 or 15 years ago, this was probably true. Nowadays, I don't think so much. Nowadays, I think people are way more onto it with this sort of stuff, particularly companies that are doing that kind of work all the time. Again, guys who are doing a lot of new wiring and that kind of stuff maybe don't see this a lot, but they don't need to, because they're not coming into existing installations and isolating and disconnecting and repairing stuff. For people that are repairing things all the time, this is just part of what you do these days. An important aspect of the tag system is that any person may apply a tag. It can be applied to all plants and equipment. It must be complied with by all persons. That is a really important part of it, because even if we're playing the game and making sure that we tag out stuff that we do, if other people aren't, then the system falls over. If other people are tagging stuff out and we're not playing the game, that we're going to cut off locks or remove tags or switch stuff back on when we're not supposed to, then the whole system falls over. Danger tags. Danger tags are red. They say danger, and they mean danger. So we have our danger tag on, something that I'm working on right now, right? So the danger tag means if you take this tag off, if you reliven this circuit, I might die. It does say here though that we could use and we may see those danger tags on other pieces of equipment. I think I've talked about this before, that particularly isolation valves for liquids or gases, that you'll often find that those will be lockable as well, and you can lock those and put a tag on them for exactly the same reason, right? My experience with that, underground fuel pipes, if I'm going to be doing some work on a dispenser and I need to disconnect the pipe work, then I'm going to turn the valve off going to that pipe work, if not turn the whole pump off. But if I'm going to turn that valve off, then I would lock and tag that valve as well, right? Because I don't want somebody else to come and turn that back on and I get a face full of petrol. Apart from the fact that it's really unpleasant, might set me on fire. Points to watch. All right, that's a lot of words. Everyone read that. All right. Everyone read that? Does it make sense? Questions? Removal of danger tags. Who's going to remove a danger tag? Only the person who put it there. If we have multiple danger tags on the same switch, remember we might have one of those multi-clasps so a bunch of people can put locks on. Who's going to remove them? Only your own one. So every individual who's put one on must come and take it off. So then we cannot turn that machine back on until every single person who's working on it has taken that tag off, which is their tacit approval that it can now be switched back on. This is what our out of service tags look like. I don't think I've ever really used one, to be honest. Like I said, mainly for me, it's always been as long as I've got some sort of tag on there. I mean, that's what the law says. All that section 106 of the regulations say is that you must attach a suitable tag. It doesn't say it has to be a danger tag for this or an out of service tag for this. It'd be nice if you followed it like this and everyone did the same thing. But worst case scenario, if you just attach a danger tag all the time, that is what it is. As long as it's got a tag on it that says don't use it. But the technically, the way we use these, remember, danger tag is for something I'm working on right now. Out of service tag is something that I have worked on. I'm not currently working on it, but I still don't want anyone to switch it back on. Machinery or equipment with out of service tags fixed to it must not be turned on without direct permission of the supervisor or person in charge. So we never remove an out of service tag unless the supervisor or person in charge has been informed and the equipment involved has been cleared for safe operation. Remove only after it's safe to do so. All checks and tests have been made and the equipment is ready to be started. So depending on the workplace, you might have different systems for out of service tags. It may not be only the person who put it on. Individual workplaces, particularly ones where maintenance is happening all the time and you might have shift changes and that sort of stuff, they may have some other permitting system where one person can take over other person's permit or something like that, or a certain level of person is allowed to go and remove out of service tags and put things back into service. But if that's the case, then that should be clearly identified at the workplace and you'd be trained in that sort of thing. I mean, those kind of systems have their own potential for danger, right? Anytime you've got somebody else removing a tag that someone else has put on, you get problems. A good one, we might watch it at some stages. I think it's on YouTube. There's a really good case study of the Piper Alpha oil platform disaster. Does anyone remember that one? You know what I'm talking about? I think it was a BP oil platform in the North Sea. It was like in the 80s, and they had no one remembers. I didn't think I remember. Like a movie. I'm not sure. There's a good documentary somewhere. It's about an hour long, and it goes through what happened. And essentially, it came down to a failure in the permit system where somebody, what happened? Somebody signed off a permit that they shouldn't have. There was something got confused in a shift changeover, and they turned on a valve that had actually been disconnected, and so all that was covering that valve was just a steel plate. And once it pressurized, there was that steel plate wasn't really designed to hold that pressure in, so it burst, and then you had just gas flowing out into the platform, which caught fire. And then all sorts of other shit went wrong after that. Like once I figured it out, like fire, people dying, all sorts of crazy stuff. They're evacuating the platform and they shut off the gas supply. But the other platforms in the area, which were all connected to a common pipeline back to land, didn't shut down because they didn't want to get in. Seriously, didn't want to get in trouble because they're like, man, it costs millions of dollars an hour to shut that pipeline down. So they didn't want to shut down. So the pressure coming out of those platforms was going back up to the one that was on fire, even though they'd shut down their supply. I know, shady, eh? I know, and then what happens? That was a long time ago, and then they still have these crazy shit happening. Yeah, lots of people died in that one. So there was some sort of room at the bottom of the platform, I think, which was like an emergency room if you couldn't get off. It was all sealed and stuff. But the fire was so intense that the dudes that went in there cooked. I literally cooked it in that room. It was fireproof, but the whole thing just... And there was like people leaping off the platform like 100 meters into the water and stuff and splatting on the... dying when they hit the water and all sorts of crazy shit. Can you imagine that? Just being in an oil platform out in the middle of the sea with no hope of getting off and the damn thing's on fire. Ooh. So you be careful without a service tax. All right, that's the end of that one.